Okay, anhydrous sodium carbonate. So anhydrous meaning without water, is used as a primary standard. What criteria are used to determine if it's a substance can be used as a primary standard? It has to be pure, has to be whatever the molar mass you're working out, it has to be all of that, nothing else. So it can't decompose, as in some things deteriorate over time, easy to store, which they don't have to have something else to react with. Sometimes they just break apart into different molecules. So it has to be stable with a known chemical formula. So it can't react with anything else and it can't break up itself. Okay. How do you prepare a standard solution of anhydrous carbonate? So you dissolve an accurate mass, so you have to weigh it out on scales accurately. Dissolve it first and then make it up to a mark in a accurately measured volume, so in a volumetric flask using deionized water, so water that doesn't have anything else with it. Volumetric analysis was performed and the following 5 were obtained. So you have to have at least three, you can have more, but concordant is generally 3, that are within 0.1 of each other. So the lowest here and the highest are within 0.06. The others, 25 and 0.02, is too high. Okay, what is the average volume? So you just add them all together, divide them by 3. Student uses aliquots so from the pipette going into the conical flask of hydrochloric acid to determine the concentration of ethanol. So this time, the thing that they're trying to find is in the burette. What should the student use for the final rinsing of each piece of glassware? So you're always, for the burette and the pipette, rinse them with whatever's going to be put into them. So if the aliquot is going into the conical flask, that came from the pipette, so that'll be hydrochloric acid, and then the burette would have been ethanamine. The conical flask, you just rinse it with water, not with either one of these, because otherwise you're going to contaminate it with reactants. A student accidentally rinsed the pipette of this, needed to take an aliquot of standard solution, so the pipette had hydrochloric acid in it. So they accidentally rinsed it with water, which would have diluted the hydrochloric acid. What would the effect be on the aliquot? So it's diluted, whatever the hydrochloric acid in the conical flask. What would be the effect on the determined concentration of the unknown? So you're trying to work out the ethanamine in the burette. So if you've diluted what you've put in there, you've put in less moles in the aliquot, so you would need less moles from the burette. So if you need less moles from the burette, then the volume that you're going to be delivering to get those less moles will be less. So if the volume has gone down, then it means, when you think about it, if you've got something in the conical flask and you're adding something, if you need less, if you think there's the same amount here, and so you're going to need the same amount of moles, if they're in a smaller volume, then it must be more concentrated. So if this number is lower, mathematically, it will make that number larger. So if you put the known one in the conical flask and dilute it, then it makes the one that you're trying to work out the concentration higher, which is the same as the question on the first page, but just putting things in the different spots, the known and the unknown. Oxalic acid has got 2 hydrogens which can be donated. It's a diprotic acid. Just get used to ignoring all the bits and pieces that aren't relevant. To determine the concentration, so we're trying to find the concentration of the oxalic acid. They titrated against a standard sodium hydroxide. Why can't the chemist prepare a standard solution of sodium hydroxide from solid sodium hydroxide? So you can't use sodium hydroxide or hydrochloric as a primary standard. You'd have to standardize them. You can't use it as a primary standard because I've got reacts, that's not really correct. It absorbs water from the air, and then carbon dioxide in the air dissolves in that water and forms carbonic acid, and the carbonic acid reacts with the sodium hydroxide neutralizes some of it. So there's a few things going on here. You don't have very much sodium hydroxide because it's like less sodium hydroxide because it's been reacted with the carbonic acid, and some of the weight that you're weighing out when you measure it, some of the weight's actually water as well. But you can use sodium hydroxide once you dissolve it and make it up. If you react that with the primary standard and work out the concentration of what you got, then you can use it as a standard. So if you look in your data booklet, you'll find that the values of methyl orange are either side of 3.4. The same for phenolphthalein, the same for phenyl red, and the same for methyl red. Okay.